Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 22 in which we are going to discuss complex analysis. Okay, and before starting the class, I would request everyone who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are absolutely free of charges and are going to help you to crack the examinations related to physical science. Okay, so I'm going to start now. Okay, so complex analysis. Okay, complex analysis complex analysis okay, complex analysis. So I'll start with basics. Okay, so z equal to x plus iy, we know, right, where x is real and this term is imaginary. Okay, and I'll draw the diagram as well. Okay, this is a circle. Okay, and this is x-axis, that is real axis. This is real axis, and this is y-axis, right, that is imaginary axis. Imaginary axis. Okay, and this is theta, this is point any point P. Okay, this is r, this is r cos theta, and this is r sin theta in this plane. Okay, r plane. Okay, so this is point P. Okay, in polar coordinate you can write like this. Okay, okay, so mod z is going to be root x square plus y square. Okay, and mod z bar, sorry, z bar, the value of z bar is x minus iy. Okay, so z into z bar is going to be root x square plus y square. Okay, this is first right, mod z bar is also root x square plus y square. Okay, x square plus y square. Okay, so that is mod z equal to mod z bar. Just let me check whether I'm audible or not, because many times I face this issue. I just wanted to double check. Also root. Okay, it's working fine. Well, so I'll start now. Okay, so here this one, these are the value of mod z bar and this. Okay, and from here you can get this z equal to, in polar coordinate, r cos theta plus I sine theta, right? X plus I y, right? So this is the one. In polar coordinate, the complex value is where x equal to r cos theta, y equal to r sine theta. Okay, this is in polar coordinate representation. Okay, and z mod z equal to r. Okay, we can write z equal to r e to the power I theta, r e to the power iota theta. Okay, and tan theta we can find theta, that tan theta equal to y upon x, tan theta equal to y upon, these are basic things which we have already studied, okay, in 11th 12th. So tan theta equal to y upon x and implies theta equal to tan inverse y upon x, tan inverse y upon x. Okay, this is polar form, right? Polar form. Okay, well, this is the one. Now this one, z minus mod z minus 0 or mod z equal to r, or we can write mod z equal to r. This means we know it, but I'm just writing it. Okay, a circle of radius, basic things. Okay, a circle of radius r, this means a circle of radius r whose are centered at origin. Okay, centered at origin. So a circle of radius r centered at origin if mod z equal to r or mod z minus 0 equal to r. Okay, this is a circle of radius r centered at origin. Okay, if mod z minus a equal to r, this means a circle of radius r centered at a. Okay, so this is it tells the center. Okay, this is centered at a, this is centered at origin. Okay, and this is the radius. Okay, I'll make a diagram for this as well. For this, for center origin is going to be this one. This is the okay, this is not looking circle, but this is circle. Consider it this is circle. Okay, guys. So this is circle. I'll try to make it a little bit better. So this is the circle. Not looking good. So this is circle. Okay, circle which is centered at origin. Okay, this center is origin and radius is r, the first one. Circle of radius r centered at origin. Okay, and similarly here this is circle of radius r centered at a. So this distance from origin is a. Okay, so there's a question, normal example, because these things are very basic but very important for solving questions. Okay, so you must know it. So example, z minus 2 mod z minus 2 equal to pi. Okay, so this means we have a circle whose radius is pi and centered at x equal to 2, right? So how we'll draw it? This one. So pi means value of pi is 3.14, right? So this is greater than 2. So this circle is going to be, this is the 2, okay, 2, and the circle is going to be like this. Centered at 2, okay. This is going to be consider it circle, guys, okay. So this is a circle, center is at 2, okay, and this is the radius, this is 3.14, okay. This is the radius, 3.14. So we can denote like that, okay, because this is the center, okay, but radius is greater than 2, right? So 3.5. So this like this will be the circle, okay, of radius pi and centered at x equal to 2, okay. So we can represent like that. And some also other basic points is, we know cos theta equal to e to the power I theta plus e to the power minus I theta upon 2, and sin theta equal to e to the power I theta minus e to the power minus I theta upon 2i, okay. And similarly cos hyperbolic theta is e to the power theta plus e to the power minus theta by 2, to the power minus theta by 2, okay. And sin hyperbolic theta value is e to the power theta minus e to the power minus theta by 2, okay. E to the power theta, this is cos hyperbolic and this is sin hyperbolic, okay, this one. Next point, and this property also know, we know that mod of sum of two function is always less than mod of sum of individual complex number, okay. Mod of sum of complex number is always less than equal to mod of sum of individual complex number, okay. So mod z plus z1 plus z2 is less than equal to mod z1 plus mod z2, okay. And similarly z1 minus z2 z1 minus z2 mod is always greater equal to mod z1 minus mod z2, okay. Mod z1 minus mod z2, that is always so mod z1 minus z2 always greater equal to mod z1 minus mod z2, okay. So this is the property. Next is next point. Okay, so now next property, mod z1 upon z2, we can write it separately. So this is going to be mod z1 upon mod z2. This is mod of z1 upon z2 is equal to mod z1 upon mod z2. This is 2 and this is 2, okay. And De Morgan theorem also we should know. De Morgan theorem, these are basic things about complex number, okay, which we have already studied in 11th 12th. So De Morgan theorem, De Morgan theorem, okay. So we know cos theta plus I sin theta cos theta plus I sin theta to the power n we can write is e to the power cos theta I sin theta is e to the power I n theta. Okay, this is e to the power I n theta, because this is e to the power I theta into n, so e to the power I n theta. Okay, or we can write like this first: cos theta plus sin I theta is e to the power I theta to the power n, or we can write e to the power iota n theta, right? And this value we know, that is cos n theta plus iota sin n theta. Okay, iota sin n theta. Okay, so this is the De Morgan theorem: cos theta plus I sin theta to the power n equal to cos n theta plus iota sin n theta. Okay, now complex analysis. Okay, these are basic things about complex numbers. Okay, so complex analysis, complex analysis, complex analysis. So existence of any limit, how to check that the limit exists. Okay, so existence 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 of any limit, existence of any limit, existence of any limit. Okay, like limit fz at z tends to z naught exist or not. Okay, so exist this will exist only when limiting value, only one only when the limiting value only when limiting value is independent independent limiting value is independent of the path when limiting value is independent of the path which path along which very important point, guys, you need to understand, along which z tends to z naught. Okay, so complex analysis, like the existence of any limit. Okay, so for existing any limit, that limit exists only when limiting value is independent of the path along which z tends to z naught. Okay, so that limiting value must be independent of the path, okay, along which z tends to z naught. Okay, I will explain it by example, like solving questions, then it will clear your doubt. Okay, okay, so question is, limit z tends to z naught z upon z bar. Okay, so we need to find exist or limit this exists or not, exists or not, exists or not. Okay, this we need to find out. Okay, so since z tends to 0, z tends to z naught, my apology, oh sorry, here in this question this is 0, guys, z tends to 0, and we need to find whether this limit exists or not. Okay, so here z tends to 0, This implies x tends to 0 and y tends to 0, right? That is origin. XY0 means origin. Okay, so now we'll put let, very important step. Okay, y equal to mx. We'll put y equal to mx. Okay, so now we'll put the value. So this is going to be limit. This is going to be limit x tends to 0, y tends to 0, right? And this is going to be this one, right? Z upon mod z. So the value of z is x plus iy, we know, right? Since z equal to x plus iy, right? So x plus iy upon mod z equal to root x square plus y square. I have already explained, right? So mod x square plus y square, right? So now we'll put the value y equal to mx. So this is going to be limit x tends to 0, y tends to 0, and for x plus, in place of iy will write mx, y equal to mx upon root x square plus m square x square, right? And then we'll solve it. So here it is going to be limit x tends to 0, y tends to 0, and here x will take common, so this is going to be 1 plus im upon, will take x common, x square common, then x square will come out of root, then this is x, and this is going to be root 1 plus m square, right? Or 1 minus m square. This is 1 plus m square. This is 1 plus m square. Okay, 1 plus m square. So here you can see, now we'll put x equal, x will get cancelled, and then we'll put the value. So this is going to be 1 plus, at x equal to 0, y equal to 0. So this is y equal to mx, right? So this is going to be 1 upon im upon root 1 plus m square. Xy we put 0, so there is no term of x and y now. So this is going to be as it is. So root 1 plus m square. Okay, so here you can see that there is a m term, right? So depends on m, so limit does not. So it depends on m, because it is written here, right? I have already explained that this limit exists only when limiting value is independent of the path along which z tends to z naught. Okay, so y equal to mx is the path, right? So m is the so it depends on m, so implies depends on m, that implies limit doesn't exist. So this limit doesn't exist. Okay, limit doesn't exists, limit doesn't exists. Okay, next is next question. This is about to check whether limit exists or not. Okay, question 2 is for this one. Okay, so this we need to check whether limit exists or not. For existing limit, that should be the limiting value should be independent of the path along which z equal to z naught. Okay, so limit, this is limit z tends to infinity, I z cube plus I z minus 4 upon 2z plus iy into z minus I whole square. Okay, this one. So we can write this. We need to check whether limit exists or not. Okay, limit exists or not. Okay, so now we'll solve it. So limit z tends to infinity. Okay, so here we can take z cube common. So this is going to be iota plus iota z upon z cube minus 4 upon z cube, right? We have taken this common. Upon in denominator also will take z cube common, z from here. So this is going to be z from here. So this is going to be 2 upon z, 2 upon z, z common, right? Z common. So this is going to be 2 plus 2 plus this is 4, guys. Okay, I4. So we can write 4i. We have made mistake. 4i. Okay, so this is going to be 4i upon z. From here we have taken z common. From here we have taken z square. That's why it is z square we have taken common. So this is going to be 1 minus I upon z cube, right? Z square, yeah, z cube into z square whole to the power z square. So that this means limit z tends to infinity and z cube will get cancelled. Okay, and will z tends to infinity, will put the value of infinity. So this is going to be I plus iz upon infinity minus 4 upon infinity upon 2 plus 4i upon infinity, 4i upon infinity into 1 minus I upon infinity whole square, right? So if we solve it, this 1 upon infinity or any value upon infinity value is 0, right? So this is going to be, we'll put that, so I plus 0 upon 2 plus 0 into 1 minus 0. Okay, so this is going to be I by 2, I by 2, right? It means this is giving the value and which is independent of the limiting value is independent of the path, right? So it means limit exists, I by 2. Okay, exists, limit exists. Okay, exists. Okay, so there is no m term, right? So it is independent of the path. So I by 2 is that means the limit exists for this expression. Okay, next question. Question third. The question at the top, that point is differentiability of complex function. Okay, differentiability of differentiability differentiability of differentiability of differentiability of complex function. Differentiability of complex function. Okay, this we are going to check. Differentiability of complex function. So we'll check whether the complex function is differentiable or not. Okay, how to check it? Well, so for checking differentiability of complex function, that is fz equal to limit delta z tends to 0. Okay, fz plus delta z minus fz upon delta z. Okay, so this is by this formula we will check the differentiability of complex number function. Okay, limit delta z tends to 0 fz plus delta z minus fz upon delta z. Okay, and fz is independent of path. Okay, this is independent of path. Okay, now I will solve it by question. Okay, I will explain it by question. So question is fz equal to given 4x plus y plus iota 4y minus x, 4y minus x. Okay, so this is so we need to check differentiability, whether it's differentiable or not. Okay, 4x plus y plus iota 4y minus x, 4y minus x. Okay, so here I'm going to solve it. So here x equal to, will write x plus, x tends to x plus delta x will write. Okay, and y tends to y plus delta y. Okay, and the value of delta fz, delta z is going to be delta x plus iota delta y. Okay, these are the value. Now we'll put it here. So now we'll find the value. So this is going to be, now we'll find f z plus delta z will find. Okay, so instead of x we'll write x plus delta x. Okay, instead of y we'll write x plus y plus delta y, and in place of delta z we'll write delta x plus iota delta y. Okay, so f z plus delta z is going to be, this is going to be, we'll write the value 4x means x plus delta x plus y, x plus delta x plus y plus minus iota 4 into y plus delta y. Okay, minus x plus delta x, right? This one. Okay, iota from our side. So now we'll write function of f this is going to be f, we'll find f delta x, this is going to be f plus delta x delta z, f this is going to be f z plus delta z minus fz. Okay, so this is the fz, f plus delta z, this is fz. Okay, we'll subtract it. So this is going to be, so you can see 4x will get cancelled, delta x will 4 delta x will remain. Similarly here, right, very easy calculation. So this is going to be, this value is going to be 4 delta x 4 delta x 4 delta x 4 delta x plus delta y minus iota 4 delta y minus delta x. Okay, so now f z plus delta z minus fz, because this is the condition for differentiability, right? This one. So we'll find this value. Okay, upon delta z. Very simple. Instead of x we have written x plus delta x, and instead of y we have written y plus delta y, and delta z value we know, that is x plus delta x plus delta iy, right? So here this is going to be this value is going to be, we'll take limit delta z tends to 0, right? So delta x tends to 0, delta y tends to 0. Okay, so this value is going to be 4, this value is 4 delta x plus delta y plus iota into 4 delta y minus delta x upon del z value is del x plus iota del y, limit this is delta z equal to 0, right? Delta z equal to 0, so this is going to be limit x tends to 0 and y tends to 0. Okay, so now we'll solve it. Okay, so this is going to be limit x tends to 0, y tends to 0. Okay, and this is going to be, will and also we'll put y equal to I delta y equal to delta mx, delta y equal to delta x, delta mx, delta y equal to delta m delta x. Okay, m delta x, we'll put this. Okay, so this is going to be limit and delta x will take common, so this is going to be, we'll put the value of delta x first. So this is going to be delta 4 delta x plus delta y value is m delta x, right? M delta x plus iota 4 delta y value is m delta x, right, minus delta x upon delta x will remain as it is, and iota delta y equal to m delta x. Okay, now next is next limit delta x tends to 0, delta y tends to 0. Okay, and this is going to be, here we'll take delta x common. Okay, so this is going to be delta x we have taken common, and what is the thing remaining? Delta x taken common, the 4 is remaining here, there is m, there is iota m, and this minus 1, right? This is going to be 4 plus m plus 4mi minus I. Okay, upon delta x we have taken common in denominator, so 1 plus im, 1 plus iota m. Okay, so now this is going to be, this will solve. Now we'll put x tends to 0, y tends to 0, x equal to 0, y tends to 0, delta x tends to 0, delta y, right? This value, this x is going to be going to get cancelled, so value is going to be 4 plus m plus 4 mi minus iota upon 1 plus im. Okay, so this value is going to be 4, will take common, so it's going to be 1 plus iota m in from these two, plus this is going to be minus iota common, minus iota common, and this is going to be 1 plus m. Okay, upon 1 plus m plus m, and 1 plus m, 1 plus 1 plus m im, and 1 plus im this one. Okay, im, because then it will be this value. So this is 1 plus im will take common, 1 plus im will take common, so this is going to be 4 minus I upon 1 plus im. This is 1 plus im, guys. Okay, so here we have taken minus I comma, if this is I square. Okay, then this value got this will get cancelled, and value is 4 minus iota, and which is independent of the m, right? And the value is independent of the path along with z equal to z naught, right? So this is 4 minus iota, that means it is differentiable. differentiable. Okay, differentiable. Next question. Next question is, so fz equal to 2x plus iota y. Okay, so from here we'll find fz plus delta z, right? So this is going to be 2x plus delta x, right? In place of x we'll write x plus delta x plus iota, in place of y plus delta y, right? Now we'll find fz plus, this is okay, fz plus delta z minus fz. This value is going to be 2x will get cancelled, so it is delta 2 delta x plus iota delta y. Okay, since we know delta z equal to delta x plus iota delta y, right? So here we'll write now fz plus delta z minus fz upon delta z, limit delta z tends to 0, delta z tends to 0. This is going to be 2 delta x plus iota delta y upon delta x plus iota delta y, and limit delta x tends to 0 and delta y tends to 0. Now we'll put this one, delta y equal to m delta x. This value will put, right? So this is going to be limit delta x tends to 0, delta y tends to 0, and this is going to be 2 delta x plus iota delta. Instead of delta y, we'll write, instead of this, iota m delta x, right? M delta x upon delta x plus iota m delta x, right? From here we'll take delta x common, right? And delta x is going to be cancelled, and this value is going to be 2 plus im upon 1 plus im, right? So here you can see this is dependent on m, means this is dependent on the path, right? Path at z equal to z naught, right? So this means it is not differentiable, not differentiable. Okay, easy question. Next question we are going to solve. Next is a complex analytic function. Okay, we'll solve question as well. So complex analytic function is the point. Complex analytic function. Complex analytic function. Okay, so a function fz, a function fz is an analytic at z equal to z naught if at z equal to z naught the function is the function is defined and differentiable. Okay, okay, so a function fz is an analytic. It is called analytic if at z equal to z naught. Okay, that should be defined and differentiable. Okay, so I'll write Cauchy Riemann equation. Okay, Cauchy Riemann equation, CR equation we call it. Okay, Cauchy, you can write CR equation, Cauchy Riemann. Okay, so this is CR equation, very important. CR equation for analytic function will solve many questions, and these questions are asked in CSIR, NET, GATE, and other exams. Okay, so so any function fxy equal to u x comma y. U is function of xy plus iv. V is also function of xy. Okay, so this is so fxy, and there's a function which is a function of xy, is 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 in this form uxy, which is u is the function of xy plus iota v xy. Okay, v is the function of xy. Okay, if in this form, this is real part, this is real part, and this is imaginary part, imaginary part. Okay, so in that case, if this is analytic function. Okay, this is analytic function, then this will satisfy these two conditions. Okay, del u upon del x equal to del v upon del y, and second condition is del u upon del y equal to minus del v upon del x. Okay, these are very important, and we'll solve question, then it will clear your doubt. Okay, so this is also called necessary condition. Okay, necessary condition, necessary condition, necessary condition. Okay, well, necessary condition. Now I'll solve question, then things will be clear. Okay, so we need to question is, we need to find fz equal to given sin z. Okay, sin z, and we need to find whether it's analytic or not, is analytic or not, is analytic, analytic, is analytic or not. Okay, so fz equal to sin z is analytic or not, that we need to find out. Okay, so we have given fz equal to, I'm going to solve this. Fz equal to, we can write sin x plus iy, right, because we know z equal to x plus iy, right, and we'll open it with sin a plus sin b, so it is going to be sin x in sin x into sin cos iy plus cos sin a sin b cos a cos a sin b, right, sin x cos iy, right, plus cos x sin iy, right. So we have just open it by sin a plus b formula, sin a cos b plus cos a sin b, right, and now this is going to be sin cos ia value is cos hyperbolic y plus cos x, sin iy value is iota sin hyperbolic y, right. I'll write it. So since very important, cos iy value is cos hyperbolic y. Okay, and cos sorry, sin iy value is iota sin hyperbolic y. Okay, very important. Okay, this you need to know. So we have put it. Now function fz is going to be sin x cos hyperbolic y plus iota cos x sine hyperbolic y, right? So from here the value of u is this is u and this is v, right? Now we will find out. So here u is sine x cos hyperbolic y and v is cos x sine hyperbolic y. Now we'll find del u upon del x, that is going to be cos x sin x, differentiation cos x, and cos hyperbolic y remain as it is. Okay, now we'll find dv upon dy, this, so cos y cos x sin hyperbolic y means cos hyperbolic y, differentiation of sin hyperbolic y, cos hyperbolic y. Okay, so and now this, so this means this has this equal to dv upon dy. First condition is satisfied. Okay, next, now we'll find dv over dv or du over dy. Okay, du over dy, so this is going to be du over dy, this one, sin x cos hyperbolic y is sin hyperbolic y, right? So sin x cos sin x, and then dv over dy is sin x sin hyperbolic y, right? For this u, sin x is sin x with dv upon dy, y means cos sin hyperbolic y. Now dv upon dx will find, dv upon dx, this one, dv upon dx, so sin x will remain, sin hyperbolic remain as it, cos hyperbolic x is going to be minus sin hyperbolic x, minus sin x, and cos hyperbolic that is sin hyperbolic y, so from here you can see del u over del y equal to minus del v over del x. This is second condition is also satisfied, so implies CR equation satisfied. CR equation satisfied implies fz is an analytic function. Okay, so we have to find, so we have seen that in this function the CR equations are satisfied, that means the function is analytic function. Okay, well, so this is the one. Next question, which is asked in just 2015. Okay, so just 2015 question. Okay, so this question is fxy is given, that is phi xy plus I psi xy. Okay, so this is the fx function is given, which is function of xy. Okay, is an analytic function, is an analytic is an analytic function, is an analytic function if phi xy equal to x square plus 4x minus y square plus 2y. Okay, so phi x is given this, so this function is analytic, which is already given. Okay, so is an analytic function, so we have been given phi xy value is given, and this, and psi xy we need to find. Okay, so means we need u is given, we need to find. Okay, so this is x squared 4x plus minus 2y squared 2y. Okay, plus 2y, this is given. Okay, so I'm going to solve it. And options are given, guys. Option is 2xy minus 4y minus 2x plus c. Option B is very good question. 2xy minus 2x plus 4y plus c. Option C is 2xy plus 4y plus 2x plus c, and option D is 2xy plus 4x minus 2y. Okay, so this is the question. So we can say this u, we can say this is v. Okay, so u is given, v you need to find out. Okay, so we'll write it. First we'll find del u. So CR equation we know, right? So first we'll find del u upon del x equal to del v upon del y, and the second equation we know, del u over del y equal to del v over del x minus, right? So del u over del x, so u is this is u given. Okay, so this is u, guys, given. So del u over del x is going to be 2x plus 4x, 2x plus 4, 2x plus 4. Will differentiate with respect to x, right? 2x plus 4. It is going to be 2x plus 4, 2x plus 4. This is going to be dv upon dy, dv upon dy. So it means dv equal to 2x plus 4y. This is y, right? Y into y. Integration plus constant c1. So this is going to be v equal to 2xy plus, if this is 4, guys. Okay, so 2xy plus 4y. Okay, this is the value of v plus c1. Okay, similarly from here, del u over del y, this one, del u over del y, del u over del y with respect to y, so minus 2y plus 2, minus 2y plus 2 equal to minus 2y plus 2 equal to minus del v over del x, right? So will minus will, this is going to be del v over del x is going to be 2y minus 2, and del v is going to be 2y minus 2 del x. Integration plus c2, right? So this is going to be v equal to 2yx minus this is 2, okay, 2x plus c2. So this means value of v, that is psi xy, is going to be 2xy plus 4y minus 2x plus c. Okay, this is common. 2xy, this is 2xy, guys. Okay, 2xy and 4y minus 2x plus c. Okay, so which option is matching? 2xy minus 2x plus 4y plus c. So option B is matching, 2xy minus 2x plus 4y plus c. This is the answer, guys. Very important question. Okay, guys. So, well, so today I have taken 3 classes. First, quantum mechanics class I have taken, and second I have solved 2019 December CSIR net PYQ, and this is the mathematical physics class in which I have explained complex analysis. Remaining part we are going to solve in, we are going to discuss in next lecture. Okay. So before ending the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. Okay guys, thank you so much. Bye now. Good night.